Result. We use the multiple linear regression model and they views as analyzed software. Here we observe two regressions. The first with a standard deviation for the dependent variable of 209.47, which means that the variance is very high. To eliminate the variance and give stability to the regressors, we apply logarithm to each variable to give stability to the model. After stabilizing the variance, in the second regression we observe the determination coefficients. These are low with high p-values. For example, the R-squared is 0.49 and the adjusted R-squared is 0.46 with significant p-values, being the price of the significant copper and the exchange rate a little less significant. Despite these results, it doesn't mean that the model is not significant, since if we look at Fisher p-values, it is 0. This means that globally model is significant. To prove that the model is consistent, we analyze the assumptions of the model. First, we analyze whether there is linearity between the variables, copper price and exchange rate with Peru's copper exports. For this, we verify by means of scatter charts. Here, we can see in the first graph the international copper price with respect to Peruvian copper exports. The variability is more adjusted. In the second graph, the real exchange rate with respect to Peruvian copper export is more variable, but both they have a positive and linear trend. The correlation matrix indicates the degree of correlation between each pair of variables. We are interested in the independent variables being closely related to the dependent variable, so that it can explain its variability well. In addition, the matrix also shows that there is no multicollinearity, since the values of the variables are not very close to 0. Now, to check the normality of errors, we apply the errors normality test. Here we observe Harke-Vera results, in this case with a p-value of 0.05. We must say that at a significance level of 0.05, we can say that the model follows a normality distribution of errors. Here we observe the initial equation and the values of the resulting equation. It is interpreted as follows. For every 1% increase in the international copper price, Peruvian copper exports will increase by 1.45. For each 1% increase in the real exchange rate, Peruvian copper export will increase by 0.57. Now that we see that the model is consistent, we can contrast the result with the hypotheses formulated. The hypotheses are: there are macroeconomic factors that have a significant impact on copper exports. There is a significant impact on Peruvian copper export due to the variability of the international copper price. And there is an increase in copper export from Peru due to the variability of the real exchange rate. With the results obtained from the model, we understand that if there are international factors that have an impact on Peru's copper export, therefore we accept the hypothesis. Finally, to conclusions. Peru is a developing country that depends on the macroeconomic condition of developed countries. That is why Peru doesn't set that a condition when it carries out copper export abroad, but accepts the conditions that are set by the most developed countries. This means that if international factors vary, Peruvian copper exports also vary according to the impact that international factors on them. As we see in the table, in the first quarter of this year, copper export fell due to the COVID-19 pandemic. For example, until February, exports were $1,024 million in for value, and in April it only reached $512 million in for value. This because international factors such as the demand and the international price decreased. The international price in February was $231 per pound, and in April it was $207 per pound. With respect to the real exchange rate index, there is no significant variation. It decreased from 96 to 92 points. That's all. Thank you.